Greetings, I'm Professor Hobo, and welcome to another HOBOTECH News product review. Today's product is one that I was asked about literally hundreds of times since it hit Indiegogo a little over a month ago. It took quite a bit of begging and pleading by many of you on their social media and about a month of trading emails with ZeroBreeze to finally get the prototype. What is it? It's the ELECHIVE 2200 solar generator by ZeroBreeze, of course. With already $1.5 million in funding on Indiegogo, everybody wants to know, is this thing any good? Let's find out. So I'm certain you're going to ask, what did the ELECHIVE come with? Well, it came with the AC wall charger, this high-tech adapter. Now, obviously, this was a quick solution to get the output on the back testable, and these paper instructions that say more what you can't do with the ELECHIVE than what you can do. In other words, they're saying this is an extreme prototype, tons of things don't work, but they're promising that these things will work in the final production. So let's go over the list of things that don't work. So here are the claims: smallest 2400 watt hour portable power station on the market, 2200 watt power output. There's a disclaimer there. Fast charging with 800 watt solar and 1250 professional charger. I don't know what that means. And it says it's silent, which, are they trying to say there's no fans in this whatsoever? I guess we'll find out. It does say it works while charging, in other words, has pass-through charging, comprehensive display information, and auto on while charging. So here are some of the instructions. It says here that the regulated output of 13.2 volts is currently set at 9 amps. It'll be upgraded to 180 watts in final production. That seems to be quite a bit for a cigarette lighter, but we'll test that. It says the 5521 connector also supports 9 amps, 120 watts, or 180 in final production. And then it says here, 2 QC318 watts. USB Type-C says full power delivery, 60 watt bidirectional. That means you can charge it from the 60 watt power delivery port. And this is confusing. It says USB Type-C 18 watts. I think they mean Type A. Down here it says, because it's a prototype, each socket's only rated at 10 amps. Means its rated output power is only 1000 watts. We will definitely make each socket work at 2200 in the final production. You can make it work at 2200 watts in a short time if you use 1100 watts on each socket. So that's how we'll test the inverter on this. We'll do it with 2 sockets. It supports 35 volts to 150 volts on the Anderson connector input, 15 amps maximum, 800 watt max. And then the 5521 connector on the back charges from 12 to 30 volts and is rated at 120 watts. Then they have a 4-pin aviation connector, which we don't have to go over that because that's kind of confusing. This is how you can charge their air conditioner through that port. But then they have this EC8 connector, which is what this is. It says it handles 1250 watts, 25 volts at 50 amps, quick charging input connector, added at the request of backers. Now, we'll have to test that and see what we're getting, if it's just an input or an output, but something like this looks like it might be a direct connection to the battery. It says all the input ports will be able to be used at the same time. This prototype only supports charging from one port at a time. Well, that's a real shame because that's one of the major features. All charging power will be displayed on the screen. Solar charging and quick charging power is not displayed on this prototype, so we're gonna have to figure out how much power is coming in, because they're saying here that while you're charging it, it's not going to even come up on the screen. It says you can check the capacity by turning it off and on again. Gee, doesn't that sound familiar?
Hello, IT. Have you tried turning it off and on again?
The ELECHIVE will be auto on when charging. For a prototype, there's still software bugs on the display. They suggest you turn it on before charging so that the capacity will be displayed correctly. The hours to full will be displayed as long as the switch to hours to empty. Right now, it looks like it's only hours to full. The display screen will be improved with a better angle and brightness. Each AC output socket will be able to work at a full 2200 watts in the final production. Features and specifications. This uses a 2400 watt hour, 1000 cycle lithium ion battery. Now, ELECHIVE calls this a ternary battery, which is just a fancy way of saying it uses 3 metal oxides in its construction. In this case, it is lithium nickel manganese cobalt oxide, or in other words, NMC. Same technology that Jackery and BLUETTI and most others use. So unlike other companies, they're not using the little 18650 cells, which waste a lot of space and waste a lot of weight. So they just are deciding to use the larger automotive grade cells. Now this is the same approach that BLUETTI has taken over the past couple of years, so it is not really groundbreaking technology. Now I wanted to make this clear because I got lots of messages, lots of comments asking me if this is some kind of space age alien technology they're using to get this to be so small. No, it's not. They just got very compact cells. There's nothing really revolutionary about it. As for size and weight, this is 13 inches by 10 inches by 9 inches, and they claim it only weighs 34 pounds. However, when I weighed it, I came up with significantly more. So here we go. Almost 42 pounds. So it is technically 6 pounds lighter than the EB240. It's still no lightweight. You're not going to toss this around like a football.
Football? Football? What's a football?
But as for the size, it's pretty impressive because here's a Jackery Explorer 300. Look at the size. This has a 300 watt-hour battery. This has a 2400 watt-hour battery. 8 times larger. And this is, well, probably about a third of the size, but you can see next to each other, this little 300 and this 2400, it's pretty impressive what ELECHIVE has done in getting this packaging together. Now as for build quality, this is a very early prototype and quality is on par with other prototypes. There's glue, misaligned things, there's a lot of stuff not working. We're gonna go over all that here in a bit. However, the design is very compact and it has these built-in handles. So it's very, very easy to carry. In fact, I carry it around with just one hand. It's actually not super heavy. And since it's so small, it's kind of easy to throw around. Now, one thing you're gonna notice in my test is that the display is very poor. It's very dim, hard to see. A lot of things on it don't work, but they do promise this is going to be fixed in the production model. This is just a prototype. As for the inverter on this, it's a very impressive 2200 watt pure sine inverter with a 4000 watt peak. And they do offer 4 outlets. Now in this prototype model, these outlets are only 10 amps each, which means I can only pull about 1200 watts out of each one. And of course, this has an MPPT controller in it, which I found was actually pretty good. There are 4 ways to charge this. It does come with its own AC power brick, which is rated at 24 volts, 10 amps, good for 240 watts. This takes 10 hours to charge this, so it's a really long, slow process. Solar, it does accept 800 watts of solar up to 150 volts in series, so it's very impressive. And you can charge it through solar in 4 hours, so that's very good. You can also charge this from a 12 or 24 volt car or vehicle, and at 12 volts it's going to take a whopping 20 hours, but you can never expect car charging to be quick. Now they do say that on the back of this, there is this EC8 output. Now they're saying as part of the Indiegogo campaign stretch goal, they're going to offer a fast charger, which is 1250 watts. It allows you to charge this thing in just under 2 hours, which if that actually happens, that'll be fantastic. Now as for 12 volt output types, this does have a 12 volt cigarette lighter, and all 12 volt on this is regulated at 13.2 volts. And that includes the 12 volt output cigarette lighter and these 2 12 volt 5521 or 5.5 millimeter outputs. Now there are 2 types of USB ports on this. You have your 2 60 watt power delivery ports rated at 60 watts. Now these are bi-directional, which means you can actually send 60 watts into this from a solar panel or a power delivery charger and actually charge this through the USB-C ports, which is fantastic. The USB-A ports are a little bit more limiting. They're only 18 watt quick charge ports. Now, as mentioned before, on the back of this, they do offer an Anderson input, which is good for 800 watts or 35 to 150 volts. That gives you a lot of flexibility with solar. You can also charge this with a solar panel in the 5.5 millimeter port, which is good for 12 volts to 30 volts. So you do have options here. Unlike the BLUETTI AC200, which can't be charged by one solar panel, this one actually can, although with 2400 watt hours, you can expect it's going to take well over 24 hours to charge it with only one 100 watt solar panel. Very impractical. Now this Aviation Port here is actually both an input and output port. Now what this does is allows them to connect it to their portable air conditioner unit and charge it through here. So you can actually send 24 volts in on 2 pins and then out on 2 pins. It's not really something that the everyday user is going to use unless you have one of their portable air conditioners. And as part of the Indiegogo stretch goal, they have unlocked the 24-month warranty on this. So you do get a 2-year warranty with your purchase. And of course, Professor HOBO took the ELECHIVE into his secret laboratory and performed all kinds of crazy experiments on it. Final results for the ELECHIVE: 2168 watt hours, 184 amp hours, total discharge 21 hours 36 minutes. As you can see from the results, very impressive. 2168 usable watt hours out of 2400. That's 90%. Now that's industry leading. Anytime a manufacturer can do 90% or better on their battery claims, I always find that to be pretty impressive. Now this is tested from their 12-volt regulated output, which means their regulation circuitry must be pretty efficient because they're really not losing that much. Remember that all these power stations always reserve the bottom 5 to 10% of the battery capacity to prevent damage to the battery. All right, let's go ahead and test the DC output rate check on this. So we got the 12-volt. Okay, so we have the 12-volt output here. Let me show you a couple of things that are very interesting here. So I understand this is a prototype, so you're going to have things like this coming off. I guess you can kind of just stick that back in there, but I mean, that literally just falls right out. So I hope they fix that. The screen, you can't even see it. It's really hard to read. It's super dim. And again, they say they're going to replace the screen. These plugs, they're all crooked and they're kind of loose. You can tell they're slanted, cockeyed, different directions. So you have these floppy little covers, and this is where the Japanese voltage selector is going to go. You have this Anderson in there, which, well, it doesn't look like it's in there very well, but it's there. There's your 5521 input. There's your aviation plug. This is an input and output. I don't know, can you guys see that? All kinds of sloppy glue there. There's a bunch of glue down here too. So it seems pretty obvious that the ELECHIVE prototype was built haphazardly and quickly to get it out. Obviously they wanted to send a couple of these out to influencers on YouTube so that they could bump up their Indiegogo campaign. So let's get back to the testing. Hopefully we won't break anything else in the meantime. Or maybe we will. That might be a fun video. So, all right, so power on, DC out. We got a light. Can barely read the screen. Well, we don't need the screen for this example, but I can try to show you the screen up close later. Let's go ahead and crank it up and see what kind of power we can get out of the cigarette lighter port. Now, do recall they say that in this prototype version, it only handles 9 amps. So let's go ahead and start at 9 amps. Oh, and of course it shut itself off. If you don't have a load on here, it shuts off after 40 seconds. So you can see the voltage dropping a little bit. There we are at 9 amps. So most power stations can do anywhere from 8 amps to 12 amps depending on their design. So let's go ahead and crank it up. So it's taking 11 amps right now. 15 amps. No, it has dropped the voltage down to 11, but that's to be expected. 170 watts. Oh, we actually hit the limit of my little tester here. It only lets you do up to 180 watts. So we're pulling 16.5 amps, 177 watts out of the cigarette lighter port. That actually sounds a little bit too high for my taste. But we're holding almost 180 watts out of the cigarette lighter port. It's showing up here on the display 191 watts. So it actually thinks it's pulling 190 out of this socket. That's certainly getting warm. That is smelling very hot. In fact, I'm gonna go ahead and unplug it because that is smelling like it is burning. So there we go. If you guys can see that, 200 degrees, 210 degrees. I'm surprised this hasn't melted. I can tell it's not looking very good. Yeah, well over 200 degrees, 220, 230 degrees. And this is why you shouldn't be pulling 18 amps through one of these, because you're likely to start melting something and that could cause a fire. So it looks like on this 12 volt circuit, there is no safety as to how many amps or watts you can pull out of this, because it actually maxes out my tester at 180 watts. You should never really exceed 15 amps on one of these, and it's allowing me to pull 17, probably 18 amps. So ELECHIVE, I'm going to suggest in your final production model, don't exceed 15 amps for this. In fact, it maybe even want to be a little safer and limit it to 12 amps. A DC output rate check for the 5.5 millimeter or 5521 outputs. Again, they say these should be regulated at 9 amps. So let's see how many we can pull. 7 amps, 8, 9, 10. So that right there should really be the limit, because we're just running this little skinny right here. You guys can see this. We're running this tiny little 5.5 millimeter barrel plug. Now, you don't want to pull more than 10 amps out of that. But let's see how far we can go. And I'm going to do this quickly because I don't want to melt my cable. It's the only one I got. There we are at 15 amps. We're pulling 160 watts through this little flimsy cable. Well, it's already getting warm. Okay, let's go ahead and see how high we can go. 17 and a half. 19 amps. I saw it hit 19 before it stopped. I'm going to go ahead and stop this test now before I melt this cable, because it's absolutely definitely getting warm. So it looks like there is no safety on the 5.5 millimeter either. It allows you just to keep pulling power until your cable melts. Now this thing got warm, so I quit the test, but if I would have kept going at 180 watts, this would absolutely melt. I mean, this is just this tiny little cable. These aren't meant to push a lot of amps. This is good news for those of you who are expert users of power stations. You could probably find some way to really take advantage of all this output. Now, for example, this will run an air compressor, a 12 volt air compressor, no problem, because there's no limit, it seems, to what you can pull out of this. Now, it may finally stop at 18 amps, but I can't tell you without trying a different tool, because it's just maxing it out, and these ports just aren't designed for that kind of power output. Hopefully they fix this in the production version, but I can only report what I have in this version. All right, let's move on to USB testing. Now I have this 60 watt power delivery charger for USB-C, and I have my little tool on the end that will tell me the truth. Okay, well, the results look promising. You can see they're 20 volts at 3 amps. That's 60 watts. So interestingly, it says only 36 watts are coming into the ELECHIVE, although we're pumping clearly 55 watts or more. So that's an inaccuracy in the display. Again, they said don't expect accuracy on this prototype, but I do have to make note of it. Okay, so let's do the opposite. Let's see, can we get 60 watts out of the power delivery port? We're gonna do the same thing, the opposite direction. There we have 20 volts, no amps. But the screen here says 36 is coming in. That doesn't make any sense. There you have it. We can pull 60 watts out of the USB-C power delivery port. So it does support 60 watt output. And then it shuts off. Now we're just gonna pull 1 amp at 5 volts, because it seems like this thing keeps shutting off for some reason. There it goes again. So while we can pull 60 watts out of the USB-C port, it keeps shutting down. So we're going to see if there's some kind of issue with the USB. So power on, DC, plug in our load, just 5 watts. Let's hit the stopwatch and let's see. Interestingly, it says we're pulling 18 watts, and down here we're pulling 9 watts. 38 seconds. It powered down. Let's repeat this test. Let's see, what else can we use? I tell you what, let's just plug my phone in, because my phone is USB-C, and it does require about 10 watts, 11, 12 watts, something like that, to power. So let's just take all the external factors out. Let's just plug my phone in. So let's start this test over again. Now it's showing no output at all on the screen. There it goes. It quit charging my phone, and all the display is zeros now. So just under 40 seconds, the USB shuts itself off. That's a pretty serious flaw. We're gonna have to figure out if the USB-A has that same issue. So let's see if it shuts down again at 40 seconds. Okay, we're still going at the 9-watt load, and we're coming up on a minute. So it looks like the problem is just with the USB-C ports. It doesn't actually shut down the USB-A ports after 40 seconds. But now I'm curious, let's see if there is a low load limit where this will actually shut down. Now I'm pulling less than 1 watt, about 0.8 watts or 0.2 amps off the USB-A port. And there it goes. So you need to pull at least 1 watt from the USB-A port to prevent it from shutting down. So keep note of that. I do have some devices that pull less than 1 watt while they're charging. I have a little tiny flashlight, USB-A flashlight. Some little tiny batteries and little tiny devices will pull less than 1 watt. Now what you can do to mitigate this problem is just plug 2 things in, like charge your cell phone while you're charging your little device and it won't shut down. But do note, under 1 watt, you pretty much can't charge. Now that we tested the DC outs on the ELECHIVE, let's test the inputs. Now I do have the factory brick charger here. Now let's see how fast it charges from the wall charger. That's what we're getting, 240 watts. So compared to a BLUETTI AC200, this charges incredibly slow from the wall, 240 watts. It's going to take you 10 hours to charge this from an AC wall outlet. And I don't see any faster way to do this because they do give you an Anderson on the back. And I suspect if you run your own charger into this, you could get 800 watts or more because that's what the solar supports. So you could probably use the same trick that I used on the AC200 and use one of these aftermarket chargers to bump up the charge rate from the wall. So they do say the ELECHIVE does support pass-through charging. I do have it charging from the AC wall outlet, and it looks like both DC and AC work. So it does support both AC and DC pass-through charging. The max charge rate test. Okay, we have the watt meter going and we have this plugged in and it's already taking quite a bit of power. We're running 52 volts. The watts are right here on the bottom, if you can see that. 200, 300, 600, 900, boom. So it looks like what's happening is it's actually overloading my charger. So I don't know if this result's good or bad, but my 1,000 watt charger doesn't seem to be enough for this Anderson input. Now, I've never had this problem before. I don't have anything more powerful than this charger, so we're gonna have to leave that test as it is as to the maximum input. They say on the paper 800 watts, but this puts out 1,000 and it shuts it down. I actually see it pull 1,000 watts from the port, and that's just too much for my charger. What we can do is move over to the variable voltage charger and see if we can limit how much comes in. Maybe we can at least get 500 watts into the port consistently. This allows me to vary the voltage all the way up to about 48 volts, 50 volts or so. However, it is limited to 500 watts, so we're not going to be able to push more than 500 into this, but let's go ahead and start. We know that the bottom is 35 volts. So just verifying at 32 volts, nothing is going in. So let's start at 35.4. And right away, that was pretty quick. We're able to put almost 400 watts in. 390 watts it looks like. So we're maxing out the charger again. Let's go ahead and bump the voltage up. Let's just go ahead and give it everything we got. Oh yeah, we're up to 513 watts. So just to verify what they said in the paperwork, there is no input. You can see everything's zeros. So even though I'm pushing 500 watts into it, nothing's happening on the screen. So that's really unfortunate they didn't get the screen working on this, because I would actually like to see, is it consistent? I mean, I'm putting 550 watts in. Is that what we're getting up here on the screen? If it was working? Yeah, just don't know. Again, it's just something that isn't working on this prototype. Okay, now it's time to test the 5.5 millimeter 5521 input. I do have my variable voltage charger here, and we're gonna go ahead and turn up the volts until it starts working, which should be around 12. And lo and behold, we're actually getting results on the screen. So it looks like the 5521 input actually is quite accurate. So at 12.6 volts, we're pulling in over 70 watts, and it looks like it's very consistent with the input on the screen, if you can actually see the screen. And let's bump up to a 24 volt vehicle, 228 watts. And it says it tops out at 30 volts. And then as soon as it hits 300, we just passed 30 volts. So we hit 31 volts and it crapped out. So it does look like it does support about 280 watts or so on the 5521 port. Again, that's quite a bit through such a small cable. So for our last input test, I want to check this port here, this EC8. So let's go ahead and plug this in. No, I didn't make this. This came with it. So let's go ahead and test. I'm going to go ahead and turn the power station off. It is off. So let's test to see if there's anything coming out of this. So there you go, 24.5 volts coming out right now. I'm sure this depends on the level charge of the battery. So let's add the solar degenerator out of load, and then we're going to check and see, does the voltage drop? 2412, 2411, 2410. The voltage on this output goes down. So what this tells us is this is a direct connection to the battery inside. I don't even want to know what would happen if I would cross these two wires right now. It would probably be a giant spark and possibly a fire. So we're going to go ahead and unplug this now, especially now that I know that this is live, even if the battery's turned off. So the Indiegogo campaign does claim it does support dual charging, charging from both the AC and DC at the same time. In other words, from wall outlet and solar simultaneously. I did test that out. They said it doesn't work on the paperwork, but I found it actually works in practice. Now, because I did want to get this test done this millennium and I didn't want to wait hours and hours for this to charge up, I decided to ignore the warnings on the paperwork that dual charging doesn't work on this. So I decided to try it anyway. I currently have the power brick plugged into the wall, and I have my variable voltage charger plugged into the solar port. And curiously enough, it is working. I am pumping in almost 400 watts on the solar input at the same time I'm charging it from AC power. So this is a pretty cool feature. So I decided to go ahead and crank this up to the maximum 500 watts. So right now it's putting 500 watts in via solar, and we're still getting about 250 via the AC wall outlet for a total of around 750 watts. That means this thing will charge up in about 4 hours. That's certainly way better than waiting 10 hours to charge this thing from dead. And of course, if you're interested in the charger, you can get one on hobotech.tv/Amazon. Now we only have one test left to do, and I have not done this yet off camera because, as I've said in previous videos, sometimes when I push these inverters to their limit, they fry. And the way the build quality is on this, I wouldn't be surprised if we burn it up. So I'm going to do this for the first time on camera. You're going to see the results the same time I see the results. So how we're going to do this, since we can't trust the meter, ELECHIVE said I can pull 1100 watts from two separate outlets. So that's exactly what I'm going to do. I'm going to go ahead and I'm going to use two different kilowatt meters, and I'm going to use a hairdryer on one and the solar degenerator on the other. And we're going to pull 2200 watts from this thing come hell or high water. So let's go ahead and get this started. That doesn't sound very healthy. I'm only pulling 300 watts from this inverter. Interestingly, we're only getting 105 volts from the inverter, where we should be getting at least 110. Okay, it says 110 now that I have no load on it. Well, it looks like it does recover. That's very interesting. The hairdryer on low knocks the voltage down so far. I was wondering why the hairdryer sounded weird. It sounded slow, you know, slower than it normally is. Let's try high heat. And that drops the voltage even more. But it does go back to 109 volts, so that's good. There's still no fan on the ELECHIVE. I'm wondering how they're doing this, because I'm going to see what happens when I pull 2,000 watts. If there's no fan in this, I'd be pretty surprised. Okay, so under a small load, you can see the sine wave still looks pretty good. It is dropped down to 105 volts for some reason. And now under a 600 watt load, it still looks pretty good. So the good news so far is we're pulling 1350 and it says 1300 on the meter, so it is pretty accurate. Let's go ahead and add the solar degenerator to the mix. So we're at 2,000 watts, and it does kind of say that on the meter there. Interestingly, the voltages went up to 112. 2195, according to the internal meter. So there you have it. It does actually support 2200 watts. Let's see what happens when we push it a little too far. So, oh, what will we have here? Can you hear it? That's not a silent generator. That's not a silent generator at all. This is not an unpleasant sound, but it is not silent. About 65 decibels. So like I said, it's not an unpleasant sound. It's not loud per se, but they claim, and it says right here in the instructions, that it's silent. It's not silent, folks. So FYI, if you're buying this to be a completely silent generator, it is not. Now, it is silent, it seems to be when it's charging and when it's running DC loads, but once you start pushing that inverter, the fans kick on, and I knew there had to be fans in this because you can't push 2200 watts out of a little box like this without some fans to blow that extra heat out. Now, I was gonna do a new test for all these larger power stations, and that is the inverter capacity test. I was gonna do a long-term discharge at 1,000 watts or more to see how good the inverter is when it comes to efficiency. However, it didn't work out as planned. I was foiled again. All right, I have some unfortunate news about the ELECHIVE. I was going to perform my final discharge test using the solar degenerator to test the inverter efficiency. And what I was doing is I was using my variable voltage charger like I always do. I was only charging it maybe 350 watts from this into the solar port. And I noticed something really interesting on the front of the ELECHIVE, and that was the meter was full. It said it was at 2400 plus watt hours, but it was still charging at 350 watts. And I was thinking, okay, there's no way they designed this thing so it would accidentally overcharge, right? I'll let it go for about 5 minutes, and I says, you know what, this is getting very suspicious. So I unplugged the charger, went to turn it on, and now it won't stay on. In fact, it doesn't work at all. The display comes on, DC, AC doesn't work. So I managed to break it, but not using the solar degenerator. I broke it by charging it. So ELECHIVE still needs some pretty serious work. I'll give you a quick demonstration that it still, even though it is technically broken, it will still allow me to charge it at like some crazy rate, but it won't charge from the AC wall outlet anymore. It'll only charge from the Anderson port. See right there, it says 375 watts. That is what is coming in through the solar port. However, if I try to charge it from the AC wall outlet, this is what the screen does. It just blinks off and on, and everything zeros. And it won't let me turn on the AC inverter, no matter how long I hold the button in, nor the DC. And you can see right there, it's barely pulling 2 watts from the AC wall charger. So it's certainly not charging. So in conclusion, it looks like the ELECHIVE is not ready for production. They have a lot of bugs to work out. Hopefully they can get them all worked out before production. The unfortunate news is that the Indiegogo campaign on this is going to end within 3 weeks. So you have to make your decision if you want to roll the dice and throw $1,000 down on this and possibly have a pretty poor power station in the end, or they could fix all this stuff, or at least most of the stuff, and you might have a pretty decent power station. But that's going to be up to you, because to me this is a very big gamble at this stage. I actually think the LEOCH was in much better shape than the ELECHIVE when it comes to prototypes. At least I only burned out the input on that. This thing doesn't work at all right now. So that's unfortunate, but that's the way things go in the world of prototypes. So what do I like about the ELECHIVE? No doubt they have developed the smallest and lightest 2400 watt hour power station out there, and they offer it in a fantastic compact package. And with 90% of the battery usable, it's definitely one of the biggest bang for the bucks out there today. What else do I like? That 800 watt solar input and potential 1250 watt fast charge. However, I was unable to test the quick charge ability of this because the 1250 watt charger is not out yet, and I don't have anything that can supply 24 volts at 1250 watts anyway. What else do I like? The fact that it does support AC and DC simultaneous charging. It makes it great for van lifers, RVers, and others living off the grid, because it's a huge amount of power in a tiny package. Why is this so great? Because you can set this on a countertop in your RV, van, a picnic table, or anything, and literally run any appliance that you could plug into a typical household wall outlet. That's from an air conditioner to the biggest microwave you can think of, the biggest coffee pot, your Keurigs, air conditioners, electric heaters, anything you can plug into a standard household wall outlet. This will run with no problem. And with 2400 watt hours of battery, that's like 2 Battleborns inside of this tiny little box, you'll get plenty of runtime for most situations. What's a good example? If you have a 1000 watt microwave, you can microwave for 2 hours on this before the battery dies. If you have a 600 watt electric heater, you can expect to get 4 hours of runtime on it. And how many pots of coffee could you make with this? Probably 50 before you kill the battery. And ladies, yes, this will actually run your hairdryer at full blast. Curling irons, straightening irons, all that can be run on this, no problem. And if you're running one of those 12-volt refrigerators off of this, you can expect probably about a week of runtime off of one of these. Okay, and that brings me to what I don't like about the ELECHIVE, and the list is kind of long because, well, I can only judge it by what it is. I understand it's a prototype, but a lot of things on this were broken or failed. One of the things that disturbs me is they made some really tall claims for this device that I've already proven wrong. And we don't know for sure if they can deliver on these promises until the production model comes out, and that could be months from now. Now, the battery is truly 2400 watt hours, but at only 1000 cycles, that's really nothing groundbreaking. They also claim this weighs only 34 pounds when in fact I weighed it at 42 pounds, making it only 6 pounds lighter than the tried and true BLUETTI EB240. It's significantly smaller and lighter than the AC200P, but without the safe 2500 cycle lithium iron phosphate battery. So you need to pick your poison. If small and lightweight is the most important thing over cycle life or proven reliability, then the ELECHIVE may be a good gamble for you. This brings me to my next point, quality. The ELECHIVE really does have a long way to go to be a reliable and safe power station. The fact that I easily blew up the BMS or whatever I damaged by probably overcharging it at the solar input with only 400 watts when it's supposed to take 800 watts tells me it's truly not ready for the market. Of course, they have several months to fix this before the production model comes out, and I truly hope this video helps them work out the bugs. And the fact that I can't even charge it with a 1000 watt power supply through the 800 watt port without it tripping, and that it can potentially melt the 12 volt outputs with as much power as coming out of it right now. Obviously, there are either no limiters or poorly designed limiters for both input and output on this prototype. Again, I get it, it's an early prototype, I'm beating it up pretty bad, but the facts are the facts. I also wasn't able to test their claim that this could be charged down to -4 degrees Fahrenheit. But from what I saw already with the non-existent limits inside of this thing, I highly doubt they actually have temperature protection built into this. I'd probably end up blowing up the battery anyway by trying to do that test. They also need to work out all the problems with the display and the shunt and the USB ports. They do promise that the display is going to be upgraded, much brighter, much better, and they're going to fix all the issues when it comes to input and output wattage being correct on the display. They're also going to add hours to discharge as well as hours to charge, so that'll also be accurate. However, I don't think they're aware of the USB problems on this until they watch this video, so hopefully my testing in this will help them figure out the problem. Now I'm hoping this video doesn't upset ZeroBreeze too much because I do want to test their production model. When that production model is available, I'd like to get a sample of it and I'd like to put it through all the same tests and see what's been improved, what's fixed, what's working, and possibly what's not. So hopefully I'll have that opportunity. Product price. You can get the ELECHIVE right now on Indiegogo for only $10.49. That's serious amount of power for a little bit of money. That's almost 50 cents a watt hour. They do tell me the price is gonna go up soon. And at this price, it may be worth risking it. In fact, they already have $1.5 million of funding for this project. So the money is definitely there. And ZeroBreeze is a sizable company with successful products in the market. They're not likely to go anywhere. And you can bet that if you have a problem in 24 months of ownership of one of these, the warranty will be upheld. Now, I do believe that the BLUETTI AC200P is a superior product simply because it is now in production and has a much more stable inverter and a much longer battery life. And of course, it's lithium iron phosphate. However, it's massive. It's like 20 pounds heavier than this and at least twice the size, which is a problem for a lot of people. And honestly, for the price of a Jackery Explorer 1000, you can get one of these, which is more than twice the power. Again, you're going to be risking your money because we really don't know what the final production model is going to be like. And with Jackery, you know you already have a really solid performing product. It's been proven, it's been out for a while. So who's the market for this aimed at? Well, it's clearly aimed at those where size and weight are the most important factors, and those that feel that the competition is simply too large or heavy to be practical. And as for recommended solar panels, I would recommend a large solar array for this because it does have a very big battery in it. It does support up to 800 watts of solar from 35 volts to 150 volts, which means if you're going to use the Anderson input on this, you need at least 2 solar panels to reach that 35 volts. Now, I've been recommending the BOUGERV 180 watt and 200 watt solar panels for the BLUETTI AC200, and the same goes with this. They're both very similar in how they charge using solar, so anything you'd use for the BLUETTI, you'd use for this. So I'd recommend just getting as many BOUGERV solar panels as you feel necessary to charge this up. You can put at least 6 of them in series and charge this thing up in just a matter of a few hours. Now, if you're interested in the BOUGERV panels, I have a special deal for you. You can go and look in the links below in the description for those solar panels. They're also available on hobotech.tv/Amazon, where I have links to not just the BOUGERV panels, but all kinds of solar panels you can use for this. Everything from flex panels to folding panels to suitcase kits. They're all right there on one page for you. Thanks for watching. If you learned something today, don't forget to give me a thumbs up below. And if you're not a subscriber already, you know what to do. That's it for now. Till next time.
Odin commands you to like and subscribe. And clean my litter box.
Billy is in the Christmas spirit. He's got his clinky, instead of jingle bells, it's clinky bells.
Clinky bells.
Yeah. He's got his fireball, and Thor's over there waiting for a sip.
Ho, ho, ho. Merry Hobo Christmas.
And I'm wishing you all a very Merry Christmas, Happy Holidays, and a Happy New Year. Hopefully 2021 will be a little bit better than 2020.
RV Golf Guy, Z Foxfire, Jack Smith.